If you looked at the Earth from the nearest star, you wouldn't see a planet. You wouldn't even see a shadow. You would see absolutely nothing. This seems counterintuitive. We see the Earth as a massive, vibrant world full of oceans and continents. But the universe has a way of swallowing the large and making the immense feel microscopic. On February 14th, 1990, Voyager 1 was finishing its primary mission. It was 6 billion kilometers away, drifting beyond the orbit of Neptune. At the request of Carl Sagan, it turned its cameras around for one last look. The pale blue photo wasn't easy to take. The spacecraft's imaging science subsystem used a narrow-angle camera with a 1,500 millimeters focal length. It had to be carefully aimed to avoid the sun's blinding glare. In the resulting image, Earth is smaller than a single pixel. It is a tiny, fragile speck of dust, caught in a scattered beam of sunlight. It is a haunting reminder of our physical insignificance. To truly understand our invisibility, we need a scale model. Imagine the Earth as a tiny peppercorn. At this scale, the sun is a beach ball, placed exactly 26 yards away. It's a manageable distance. But then we keep going. Jupiter would be an apple, placed another 140 yards down the street. Neptune would be a lemon, half a mile away from our starting point. The space between them is just air. Even within our solar system, the distance between the Moon and the Earth is staggering. You could fit all 7 other planets in the gap between them. And yet, that gap is a microscopic fraction of the system's total size. Beyond the planets lies the Kuiper Belt. This is a vast, frozen donut of icy bodies. It is home to Pluto and Eris. It is a graveyard of the early solar system, stretching billions of miles into the dark. Even further out is the Oort cloud. Think of it as a shell of trillions of comets. These are dirty snowballs, miles wide, drifting in a permanent midnight. They are barely held by the sun's gravity. From the Oort cloud, the sun is just a very bright star. You could not see the Earth at all. Our planet's presence is masked by the overwhelming brilliance of our parent star. We are lost in the glare. If we leave our solar system, we enter the interstellar void. The nearest star system is Alpha Centauri. To reach it at the speed of Voyager 1 would take over 75,000 years. That is the distance of our neighbor. Our sun is part of the Milky Way galaxy. We are located in the Orion Arm, about 26,000 light-years from the galactic center. The galaxy is a disk of light, spanning 100,000 light-years. The Milky Way contains at least 100 billion stars. Some estimates say 400 billion. From across the galaxy, our sun is just a nondescript yellow spark, lost among a sea of white dwarfs and red giants. Imagine standing on a beach in Florida and trying to find a specific grain of sand on a beach in Africa. That is the scale of the Milky Way. The Earth is not even part of the equation anymore. It is invisible. Our sun is a G-type main sequence star. It emits 3.8 septillion watts of power. By comparison, the light reflected by Earth is a rounding error. It's like a firefly, flying next to a searchlight. Even if you had the most powerful telescope ever built by an alien civilization, Earth would be hard to find. The signal-to-noise ratio is too high. The sun's photons drown out the Earth's reflection. Then there is the issue of albedo. Albedo is a measure of how much light a planet reflects. Earth's albedo is about 0.3. This means we reflect only 30% of the light that hits us. Compared to a star, which is an active nuclear furnace, a planet is a cold, dark rock. We only glow because of borrowed light, and the further that light travels, the more it fades away. Now we zoom out even further. Beyond the Milky Way, we find the Local Group. This is a collection of about 50 galaxies. The heavyweights are the Milky Way and the Andromeda Galaxy. Andromeda is 2.5 million light-years away. It is moving toward us at 400,000 kilometers per hour. From Andromeda, the Milky Way is just a blurry smudge of ancient light. Every human who has ever lived resides within that smudge. Every war, every poem, and every empire exists inside a faint glow that an observer in another galaxy might not even notice. The Local Group is just one small part of the Laniakea supercluster. Laniakea means immense heaven in Hawaiian. It is a structure that contains 100,000 galaxies. On this scale, the universe resembles a biological web. Galaxies are not scattered randomly. They flow like rivers, along long filaments of dark matter. They all move toward a gravitational center. This center is called the Great Attractor. It is a mysterious region of space that pulls entire galaxies toward it. It is the dominant force in our local corner of the universe. Earth's existence at this level is less than a drop of water in the Pacific Ocean. We are part of a structure so vast that light takes 500 million years to travel from one end to the other. If a galaxy were to vanish from Laniakea, the supercluster wouldn't even feel it. The loss of a single planet is a change so small, it cannot be measured by any physical scale. But why exactly can't we see the Earth? The answer lies in the inverse square law. This is a fundamental law of physics that describes how energy spreads out. It is the ultimate filter. The law states that the intensity of light is inversely proportional to the square of the distance from the source. If you double the distance, you don't get half the light. You get 1/4. If you triple the distance, you get 1/9. By the time you are light years away, the photons reflected from Earth have spread out so much that they're almost gone. Imagine throwing a bucket of water into a dry, empty field. Near the bucket, the ground is soaked, but a mile away, not a single drop can be found. The water hasn't disappeared. It has just spread too thin. Light behaves the same way. The photons from our oceans are still traveling through space. But a mile away, not a single drop can be found. The water hasn't disappeared. It has just spread too thin. Light behaves the same way. The photons from our oceans are still traveling through space. But they are so far apart that they are indistinguishable from the background noise of the cosmos. This noise comes from the cosmic microwave background. It is the afterglow of the Big Bang. It is a constant static that fills every corner of the sky. It is the baseline of the universe. For a signal to be seen, it must be stronger than that noise. Earth's reflection is not. We are a whisper in the middle of a heavy metal concert. No one can hear us. Even our radio broadcasts have limitations. We have been leaking radio waves into space for about a century. This has created a radio bubble that is 100 light years wide. Inside that bubble, an advanced civilization might be able to detect us. But the Milky Way is 1,000 times larger than our radio bubble. To the rest of the galaxy, we are still silent. And then there is the cosmic horizon. Because the universe is expanding, and light has a finite speed, there is a limit to how far we can see. Some parts of the universe are moving away from us faster than light. The light from those regions will never reach us, and our light will never reach them. We are separated by the geometry of space-time itself. We are invisible by the very laws of reality. Does this mean we are insignificant? It depends on how you define the word. Physically, we are a rounding error in a vast, cold machine. We are a ghost in the dark. But invisibility is not the same as irrelevance. On this tiny, unseen world, chemistry became biology, and biology became consciousness. The universe has developed eyes. We are the way the cosmos tries to understand itself. We have mapped the Laniakea supercluster from the surface of a dust mote. We have decoded the laws of physics while standing on a pixel. Our ability to recognize our own insignificance is perhaps our greatest achievement. It requires a profound level of intelligence to see how small we really are. It is a perspective shift. The universe is vast, and it is mostly empty. It is a place of staggering beauty and terrifying scale. But it is also a place where a tiny planet can exist. Earth is invisible to the stars, but it is everything to us. It is the only place in the known universe where life has taken root. It is a precious, lonely oasis. So the next time you look at the night sky, remember the pale blue dot. Remember that you are looking out from a position of total invisibility. You are a part of the dark, but you are also the observer. You are the light that notices the darkness. We may be invisible to the universe, but we are here, and that is enough.